Good morning, dear students. My name is Ferhan Mazher, and today is 2nd of October 2021. And right now, I am with the ninth Cambridge class, and the subject we are studying is DMaths 4024. We are working on the book D3. We are studying the chapter number 1, which is related with the quadratic equations. Today, we are going to attempt exercise 1E in this session. And we will solve question number 1 and question number 2 of the exercise 1E. The questions are related with the graphs of the quadratic equations. So the basic thing will be that the equations will be given and we have to draw the quadratic graphs. And we have to first here we have to use the x-intercepts, the y-intercept, and the turning point of the quadratic graphs. So let's start today's work. Okay, so on your screen, a very important description diagrams are showing. Here you can see whenever in your chapter 5 of the D2, you have drawn the graphs of the quadratic equation. In the chapter 1 of the D3, you have also drawn the graphs of the quadratic equation. And if you look at the in your book D1, exercise 1C is also related with the graphs of the quadratic equation. Exercise 1E is again on the graphs of the quadratic equation. So here, the first thing which you should know is that whenever you draw the graph of a quadratic equation, it always makes a shape of a parabola. So parabola is that U shape. That parabola can open upward, and this parabola can also open downward. Okay, so you can see that these parabolas sometimes they open upward. We call this happy face. Sometimes these parabolas open downward. We call it sad face. And there is a certain point on which we call this the turning point. And here, this is the turning point. That can be the minimum point in the happy face. Its Y value will be minimum. Here in the sad phase, this turning point with its Y value will be the maximum in the whole of the graph. Okay, so these are the two basic shapes which always come whenever you draw a graph of a quadratic equation. Now, here I have tried to show you a parabola. It's a happy face. And you can see this parabola is cutting the x-axis at these 2 points. So these 2 points where it cuts the x-axis, they are known as the x-intercepts. So this graph has 2 x-intercepts. Here is another example. You can see here we have a parabola with a happy face. And this parabola is only touching the x-axis at a single point. So this will have only one x-intercept. If you look at this third example, here we have drawn a parabola and it's a happy face. And this parabola is not touching the x-axis. So this parabola will have no x-intercept. So there is no x-intercept in this case, this third case. So if you look at this parabola, it's a happy face, and you can look at this point and this point. In these 2 points, you can see that these are where the graph is cutting the x-intercept. So these are the x-intercepts of this graph. And here at this point, you can see that the graph is cutting the y-axis. So this point is the y-intercept of this graph. So here I have given a 5th example, and you can see that this is a parabola with a happy face. This point is where the graph cuts the y-axis. So this is the y-intercept. These 2 points where the graph cuts the x-axis, these are called x-intercepts. And this point where the graph takes a turn, that point is called the turning point of this graph of the quadratic equation. So these 4 points or you can say 3 points, they are very important. The x-intercepts, the y-intercepts, and the most important of them is the turning point. And let me go to the next slide, and here we go. So in the next slide, you can see here we have tried to show you here. You can see in this diagram, this is an example, we have shown a happy face. And you can see in this graph, we know that the graph has x-intercepts at 1, 0 and at 4, 0. So the x-intercept is basically 1 and 4. So very easily, if you know the shape of this graph, if this graph is given to you, you can find its equation. So understand this, if you know the x-intercepts, the equation can be y equals to x minus a bracket bracket x minus b. So this is a formula, or you can say a standard form in which the x-intercepts are shown. This a and b basically represents these x-intercepts. So in the place of a, I will put 1, and in the place of b, I will put this 4, and I will get this equation. So y is equals to 1 minus x into x minus 4. Y is equals to x minus 1 into x minus 4. So that will be the equation of this graph whose x-intercepts are given. If you multiply these two brackets, you will get y equals to x squared minus 5x plus 4. So you see in this first example, what happened, a graph was given, only its x-intercepts were known, and I know that it's a happy face. So its equation will be, you can find its equation. Now look at this equation. It also, in the second equation, you can see we have a parabola. It is given, the parabola shape is given to us, and we know that it has x-intercepts. The values of the x-intercepts are 1 and 4. So this point is 1, 0. This point will be 4, 0. These are the x-intercepts of this graph. But and they are same as this one. But there is a problem. There is a difference. That was a happy face. This is a sad face. If you want to find out this equation, that will be y equals to, because it's a sad face, I will put a negative outside. Same formula, but the negative outside. So you will have y equals to minus bracket x minus a bracket close bracket start x minus b bracket close. This a and b are basically these x-intercepts. So you will have minus bracket x minus 1 bracket x minus 4 bracket close. Just multiply them and open them. The equation will be y equals to minus x squared plus 5x minus 4. So you see, this is a very important rule which you should always remember. If the coefficient of x squared is positive, if the coefficient of x squared is positive, the graph will be a happy face. If the coefficient of x squared is negative, the graph will be a sad face. Look at this example. This is example number 3. Look at this example number 3. Here we have the x-intercept in the graph is shown, given to us. And if you look at the shape of this graph, you will see that the x-intercepts are minus 2 and 6. So y is equals to, because it's a happy, so y will be equals to x minus a, x minus b. A and b means minus 2 and 6. Just put those values. So x minus minus 2, it will become x plus 2, x minus 6. And so the equation is y equals to bracket x plus 2 bracket close bracket start bracket x minus 6 bracket close. You multiply these two brackets and you will get x squared minus 4x minus 12. So you can see that here the x squared coefficient is positive, so it will be a happy face. So now from these examples, I just want to show you that if a graph, a parabola graph, a quadratic graph is given to you, and you only know its x-intercepts, very easily you can find its equation, the equation of that graph. And the formula is y equals to bracket x minus a bracket close bracket start x minus b bracket close. If it's a happy face, and if it has a sad face, you just need to put a negative outside that brackets. And I hope you have understood. These are just examples. We just want you to learn. Okay, now we have the fourth example. Here I have shown you a graph, and in this parabola, you know the x-intercepts are given. The one x-intercept is minus 2, and the other x-intercept is 6. And it's a sad face. And if it's a sad face, you can find this equation. and the formula for the equation is y if the x-intercepts are known. Then the y is equals to minus bracket x minus a bracket close bracket start x minus b bracket close. Because it's a sad phase, so that's why I have put a negative outside. So in the place of a and b, you need to substitute these values minus 2 and 6. So if in the place of a I put minus 2, so this will become x plus 2. In the b I substitute 6, so it becomes x minus 6. So this is the equation, minus bracket x plus 2 bracket close bracket start x minus 6 bracket close. If you multiply these and then multiply with minus, the final equation will be minus x square plus 4x plus 12. So you can see that here the coefficient of the x square in this equation is negative. That's why it's a sad phase. Now the next example number 5 is now the strategy will change. Now we will have if the turning point is given, it's a different situation. The first 4 examples which I tried to show you were when a parabola is given to you and the x-intercepts are given. Now we have a different, the situation. In this situation, you have a parabola, and the graph is given, and we know only its turning point, and we know it's a sad phase or a happy phase. For example, look at here. Here we have a parabola, and the coordinates of its turning point are given. The coordinates of the turning point are 2, minus 3, and it's a happy phase. If this situation is given to you and we want to find out the equation, the process is very simple. Here we have a standard equation for this. Y equals to x minus p bracket close whole square plus q. This p is the x coordinate of the turning point, and this q is the y coordinate of the turning point. So I just put these values in the place of p and q. So y equals to x minus 2 whole square plus, and the y value is minus 3. So in the place of q, you put minus 3. So you will have x minus 2 whole square minus 3. So if you open it, x minus 2 whole square minus 3, if you just simplify it, expand it, the final equation will be x square minus 4x plus 1. So you see, if only the turning point is given, we can find the equation of that graph very easily. Okay, so look at this example here. In this example, the turning point is given, the same turning point, minus 2, minus 3, but it's a sad phase. So if you know only the turning point and it's the sad phase, so you can find the equation y equals to, but because it's a sad phase, that's why I put the negative outside here. Y equals to minus bracket x minus p bracket close whole square plus q. So in the place of p and q, you just need to put these 2 values. P is equals to 2 and the q is equals to minus 3. So substitute these values here. So you will have x minus 2 whole square, and a negative is outside already, plus, and the q is minus 3. So you will have minus bracket x minus 2 bracket close whole square minus 3. So if you open it, if you simplify it, the final equation will be y equals to minus x square plus 4x minus 7. So you see, if you are given a parabola and you only know the turning point, very easily you can find the equation. Okay, so here I have just tried to give you an example so that you can understand that what kind of questions will come. So you can see here an equation is given. It's just an example, okay? Y equals to x minus 4 and x minus 12. So this form of the equation, this is a quadratic equation. If you simplify it, this will be a quadratic equation. You see x squared minus 16x plus 48. When you multiply these 2 brackets, you simplify them, you get this x squared minus 16x plus 48. This shape tells me that these are the x-intercepts of this graph. So now if you know the x-intercept, so the x-intercept, you need to change the sign. The x-intercept will be 4, 0 and 12, 0. So if you know the x-intercepts, the next thing which you need to do is that you need to find out the x of the turning point. Remember, if you know the x-intercepts, then the x of the turning point is equals to, you can find by this formula, x1 plus x2 divided by 2. This x1 and x2 means the x-intercept. So you will have 4 plus 12 whole equals to divided by 2. So you will have 8. Now, if you know the x of the turning point, put that value of the x in the original equation and you will be able to find the y of the turning point. So once you know the x of the turning point, that's the midpoint, that's the x of the midpoint between the x-intercepts. So put the in this original equation 8 in the place of x, put 8. So you can see here we have put 8 in x in the original equation. So y will be minus 16. So the turning point is 8 comma minus 16. Now, once I know the x-intercepts, I know the coordinates of the turning point, then I will find the y-intercept. Whenever you want to find out the y-intercept of an equation, of a graph, in the original equation, in the place of x in that equation, just substitute 0. So here you can see we have substituted 0. Try to show you how this graph will be drawn. And you can see I have drawn a grid and it's just a rough hand grid. And its x-intercepts are 4 comma 0. Just first plot these 2 points. The turning point is 8 comma minus 16. Plot this point, and the y-intercept is 0 comma 48. Then join them with the free and smooth curve. So this will be the graph of that this equation. Hopefully you have understood. Okay. Now we are moving to another. So you can see that here another here in example y equals to 2 minus x into x plus 3. So I need to draw the graph. This order is not right. Okay, 2 minus x is not right. It should be x minus 2 or x plus 2. X should come first and it should be positive. So what I will do, from this first bracket, I will take minus 1 common. So I took minus 1 common. So here you have x minus 2. Their order will change. The second bracket will remain as it is. So you can see this equation. This is basically the shape in which the x-intercepts are shown. But outside it, we have a negative sign, which means that it will be a sad face. It will be a sad face. So when you draw the graph, it will be a sad face. That negative means this thing. So if you open it, simplify it, and the equation will be minus x squared minus x plus 6. Okay. So from this equation, I can tell you that the x-intercept will be 2 comma 0. You need to change the sign, okay? So the one x-intercept will be 2 comma 0. The other x-intercept will be minus 3 comma 0. The other x-intercept will be minus 3 comma 0. So once you know the x-intercepts, the 2 x-intercepts of that graph, then you need to find out the x of the turning point. If you want to find out the x of the turning point, the formula is simple. X is equal to x1 plus x2 divided by 2. x1 is 2 and x1 is 2 and x2 is 3. So you just simply add them. Sorry, minus 3. So you will have minus 3 plus 2 divided by 2, and that will be minus 1 by 2. So the x of the turning point is minus 0.5. So how you get this x of the turning point? You add both the x-intercepts and you divide it with the 2. That is how you do it. And next thing, I will find the y of the turning point. How you find the y of the turning point? Once you know the x of the turning point, you simply put that x value into that original equation. So in that original equation, in the place of x, I will put minus 0.5. And you can see here, we have put that in this equation. And the y value will be 6.25. The y value will be 6.25. So the coordinates of the turning point will be minus 0.5 comma 6.25. So once you know the coordinates of the turning point, you know the x-intercepts, then the the next thing you need to know is the Y-intercept. So if you want to know the Y-intercept, you will take the original equation, and that in that original equation, in the place of x, you just put 0. So here you see, we have put in the original equation, this, in the place of x, we have substituted 0. So the y value will be 6. So 0, 6 is the Y-intercept. So what you will do if you want to draw this graph, I will draw a grid. I will locate the x-intercepts. The x-intercept is -3, 0, 2, 0. I will put these 2 points. The turning point is minus 0.5, 6.25. So I will put a point here, dot here. And the x-intercept is 0, 6. So I will join them with a parabola shape, a smooth curve like this. It will be a sad face. And that is how you do it. This is example number 2. Hopefully you have understood. So we have exercise 1E of the D3. Question number 1. Here an equation is given to us, and the equation is y equals to x plus 1 into x plus 3. And they want you to draw its graph. Okay. If you look at this equation is basically the equation in which the x-intercepts are shown. So from this equation, I can deduce that what are the x-intercepts of this graph. Okay. So this is the x-intercept and this is the x-intercept, but you have to change the signs. So the x-intercept will be -1, 0. And the other x-intercept will be -3, 0. So from this equation, I can very easily tell the x-intercept of this graph. So once I know the x-intercepts, then from these x-intercepts, I will find the x-coordinate of the turning point. And the formula is x of x1 plus x2 divided by 2. So -1 plus -3 divided by 2. So that will be -2. So once you know the x of the turning point, then I will find the y coordinate of the turning point. For that purpose, I will put this value of the x in the original equation. You can see here, we have substituted x with -2 in the original equation. So y will be equals to -2. And here we substituted the -2. And the y value will come out to be -1. So your turning point will be, coordinates of the turning point will be -2, -1. So now up till this point, I know the x-intercepts and I know the coordinates of the turning point. And the last thing which you need to know is the y-intercept. The y-intercept will be in the original equation in the place of the x substitute 0, and you can see we have substituted 0. So the y will be equals to 3. So the y-intercept coordinates will be 0, 3. So now I know these 4 points. So I will draw a grid, as you can see we have drawn here, and I will plot these points there. So I will plot -1, 0, -3, 0. The turning point is -2, -1. This point I plotted, and the y-intercept is 0, 3. And this will be a happy face because here x will be x square will be have a positive coordinate, and then I join them. So you see very easily I have drawn the graph, the graph of this quadratic equation. Hopefully you understand. Okay, question number 1B part is showing up on your screen. Here an equation is given. Y equals to x minus 2 into x plus 4. And we have to draw this graph. So x and x, when you multiply, that will give you x square, and it will have a positive coefficient. So it's a happy face. This type of equation, this tells you the x-intercepts. So I can very easily tell what are the coordinates of the x-intercepts. This one, -2, you will change its sign, 2, 0. 2, 0 will be the x-intercept. This is +4, so -4, 0. That will be the x-intercept. So this is how you write the x-intercept from this type of equation. So 2, 0 and minus 4, 0 will be the x-intercepts. Once you know the x-intercepts, you can find the x coordinate of the turning point. And the formula is x1 plus x2 divided by 2. So here x1, x2 means the x-intercepts. So 2 plus minus 4 divided by 2. So it will be minus 2 divided by 2. So it will be minus 1. So the x coordinate of the turning point will be minus 1. If you want to find the y coordinate of the turning point, in the original equation, substitute the value of the x as minus 1. So here you can see we have substituted the x with minus 1 in the original equation. So you will have minus 1, minus 2, minus 1 plus 4. So it will be minus 9. So the coordinates of the turning point are minus 1, minus 9. So up till this point, I know the x-intercepts, I know the turning point. The fourth thing which you need to find out is the y-intercept. If you want to find out the y-intercept, you only you take the original equation, and in the original equation, you substitute the x with 0. So here you see we have done that in the original equation. In the place of x, we put 0. So the y value came out to be minus 8. So the y-intercept will be 0, the coordinates of the y-intercept will be 0, minus 8. So now I know the x-intercepts, I know the turning point, I know the y-intercept, and I know that this will be a happy face. And then what I will do, I will draw a grid and I will plot these points. So 2, 0, you can see here we plotted, minus 4, 0, here we have plotted, and the turning point is minus 1, minus 9, we plotted it here. The y-intercept is 0, minus 8. And then I will join them with freehand, and this will be my parabola. This is the graph that we have. Hopefully you have understood. That was the question number 1B part. Okay, so question number 1C part is showing up on your screen. Here we have been given an equation which is y equals to minus bracket start x plus 1 bracket close bracket start x minus 5 bracket close. So clearly this equation is showing you the x-intercepts of that graph. X-intercept, here we have used a different technique. We put, whenever you find the x-intercepts, the y definitely is 0. So if you put this y, you substitute it with 0, and so it means x plus 1 is 0 or x minus 5 is 0, because these two are multiplying, and if their answer is 0, then it means either the first bracket is 0 or the second bracket is 0, or both of them are 0, so we make them 0. So you will have x equals to minus 1, x minus 5 equals 0, so x equals 5. So the x-intercept will be minus 1, 0 and 5, 0. You can do it directly also. The x-intercept will be minus 1, 0. You change the sign, okay? So 5, 0. So that will be the x-intercept. So once you know the x-intercept, another very important thing, here you can see outside we have a negative. So this negative shows that it will be a sad face. Now, once you know the x-intercepts, we have to find the midpoint or the x of the turning point. So if you want to find the x of the turning point, the process is very simple. You add up both the x-intercepts and you divide them with 2. So we will have minus 1 plus 5 divided by 2. So it will be 4 by 2. It will be 2. So the x of the turning point, x coordinate of the turning point is 2. So put this x value in this original equation and find the y of the turning point. So y is equals to minus bracket x plus 1, x minus 5. That's the original equation. In the place of x, substitute 2. So we substituted here 2. So you see we will have 9. So the turning point's coordinates are 2, 9. So up till this point, we have three things. We know the x-intercepts minus 1, 0, 5, 0, and we know the coordinates of the turning point. They are 2, 9. Then I will find the y-intercept. So y-intercept, take the original equation, and in the place of x, substitute 0. So here you can see we have substitute 0 in the original equation, and the y value came out to be 5. So the y-intercept will be 0, 5. So I know the x-intercepts, I know the coordinates of the turning points, and I know the y-intercept. So what I will do, I will draw a grid. You can see here on this side, I have drawn the grid. minus 1 comma 0, here I plotted it. Then we have 5 comma 0, here we have plotted it. Then the turning point is 2 comma 9, so here we have 2 comma 9. And the y-intercept is 0 comma 5, so this will be the point. So you join them with the free hand in the shape of a parabola, and you will find this graph. You will make this graph. So hopefully you understand this. This is how we have done question number 1, C part. Okay, so we are moving to the next question. The next question is question number 1, and it's D part. And you can see here in the question number 1, D part, we have an equation is given, y equals to minus bracket x minus 1 bracket close bracket x plus 6 bracket close. So by looking at this equation, I can tell you two things, that these shows the x-intercepts, and this negative outside shows that it's a sad face. So the x-intercepts will be, my technique is directly I can tell you the x-intercepts. You just need to change the sign of this number. It will be 1 comma 0, and the other x-intercept will be minus 6 comma 0. So the x-intercepts will be 1 comma 0 and minus 6 comma 0. Now I will find the x of the turning point. You add these x-intercepts and you divide it with the 2. So 1 plus minus 6 divided by 2, it will be minus 5 by 2. So it's minus 2.5 actually, or you can say minus 5 by 2. If you want to find the y of the turning point, you take the original equation, and in the original equation, substitute the x with this value, minus 5 by 2. So here you can see I took the original equation, and in the x, I substituted minus 5 by 2. And so we took the LCM inside, so it will be minus 5 minus 2 divided by 2. Here we also took the LCM, so it will be minus 5 plus 12 divided by 2. It will be minus 7 by 2. This will be 7 by 2. Outside we have a negative, so it will become 49 by 4. So the turning points coordinates are minus 5 by 2 comma 49 by 4. So it's like minus 2.5 comma 12.25. So now I know the x-intercepts, I know the turning point. The last thing I will try to find out is the y-intercept. So the y-intercept of this equation, I can very easily find by in the original equation. In the x for the x substitute the x with the 0. So here you know we have done that. Y equals to, in the place of x I substituted 0. So the y value will be 6. So the coordinates of the x-intercept will be 0 comma 6. Now you know the x-intercepts, you know the coordinates of the turning point, you know the coordinates of the y-intercept, and you know that this is a sad face. So I have drawn a grid here. So I plot these points, 1 comma 0, this point, and then minus 6 comma 0, this point. And the turning point is minus 2.5 comma 12.5. So I plotted this point. And the y-intercept is 0 comma 6. So because the graph is symmetrical about this turning point or this line of symmetry, so same point at this level on this side I will have. Okay, so just join them. So this is the required graph. This is the graph of this equation. Hopefully you understand this process. Okay. Question number 1, and we are on the E part here. An equation is given: y is equals to bracket start 3 minus x bracket close bracket start x plus 2. You are familiar with this type of equation, but there is a problem. The x in the first bracket, it should be x minus 3, x plus 3, whatever, but not the x should not be on the second position. So what I will do from this first bracket, I will take a negative 1 common. So you see, if I take negative common, their order will change. The x will become positive, the 3 will become negative. So here from the first bracket, I've taken minus common, then it will become x minus 3, and the second bracket will remain as it was. So due to this negative, I can tell you that this will be a sad face. Now, this x minus 3, x plus 2. So the x-intercept will be 3 comma 0. And the x-intercept will be minus 2 comma 0. So you see, from very easily from this equation, I can tell the x-intercept. So they are 3 comma 0 and minus 2 comma 0. So once you know the x-intercepts, you can find the x coordinate of the turning point. You simply add the x-intercepts and divide them with 2. So 3 plus minus 2 divided by 2, so it will be 1 by 2. So 1 by 2 means 0.5. Once you know the x of the turning point, you can put that into the original equation. In the original equation, substitute the x with 1 by 2. So here you know I have substituted x with the 1 by 2. So when you take the LCM, it will be, here we go, it should be, here I think we made a mistake, and 3, 4, 4 plus 1, 5, 5 by 2, and this, okay, it will be -6, -6 plus 1, it will be -5. There's no mistake, okay? So it will be plus 25 divided by 4. So the y of the turning point will be 25 by 4. So the coordinates of the turning point are 1 by 2, comma 25 by 4, which is actually 0.5, comma 6.25. So now I know the x-intercepts and I know the coordinates of the turning point. Now I will find the y-intercept. So the y-intercept in the original equation, this one, you substitute the x with the 0. So you will have, you can see, we use the first equation, and you will have y equals to 6. So the y-intercept will be 0, 6. And it is supposed to be a sad face. So then I will plot these points. I will draw a grid. Then I will plot these 2 points, 3, 0, 3, 0, then -2, 0. Then the turning point is 0.5. 0.5 will be here. And 6.25, it will be here. The y-intercept is 0, 6. I will plot this. And then I will join them with a smooth curve. And you will get your sad face. This is the parabola, sad face parabola. So that is question number 1 and E part. Okay, now we are on the question number 1, F part. The y equals to, an equation is given. Y is equals to bracket start 2 minus x, bracket close, bracket start 4 minus x, bracket close. So this is, you are familiar with this equation, but there's a problem. The x should not be in the second position here. It should be on the first position. So you can change, but you can take a negative common. And if you take a negative common outside, then it becomes easy. But here, my student, because this question is solved by one of my students. So her technique is, if you want to find the x-intercepts, what she do, she put y equals to 0 in that equation. She has not taken x and a negative common. So she put the y equals to 0. So you will have, if you put here 0, so these 2 brackets multiplying and they are equal to 0. So it means either the first bracket is 0 or the second bracket is 0. So I will make the first bracket equals to 0. 2 minus x equals to 0. So x will be equals to 2. If 4 minus x is equals to 0, the x will be equals to 4. So the x-intercept is 2, 0, and the x-intercept is 4, 0. So you know the x-intercepts. And once you know the x-intercepts, you can find the x of the turning point. And the formula is x1 plus x2 divided by 2. So it will be 2 plus 4 divided by 2, and that will be 3. And once you know the x coordinate of the turning point, you can find the y coordinate of the turning point. You need to only put the x equals to 3 in the original equation. So here is the original equation. In that, substituted x with 3. So the y value will come out to be -1. And so the turning point is 3, -1. So now I know the x-intercepts, I know the turning point, and I can find the y-intercept. In the original equation, what we will do, we will substitute the x with the 0 if you want to find the y-intercept. So here you can see x has been substituted with the 0. So you will find the y of the value, and that will be 8. So the coordinates of the y-intercept will be 0, 8. So I will draw a grid and I will plot 2, 0. That is the x-intercept. So here you see 2, 0. Then I will plot 4, 0. This is the point 4, 0. Then the turning point is 3, -1. So here you see 3, -1. And the y-intercept is 8, 0, 8. So 0, 8 is here. So join them with the free hand in the shape of a smooth curve. A parabola will be formed. It will be It's gonna be a happy face, okay? Because you know how this will be happy face, because this order is not good, this order is also not good. This X was supposed to be on the first position if you use my technique, okay? But her technique is also very good and you don't have to think too much. Okay, so here we have question number 2 coming up on your screen, question number 2, and it's A part. So in the question number 2A part, we have x square plus 2, y equals to x square plus 2, and you can see that it's a happy face because the x coordinate of the x coefficient, x square's coefficient is positive, so that's why it will be a happy face. We have to draw the graph of this equation, and we have to also find the equation of the line of symmetry. So it's very easy, but here I use a trick. It's x square plus 2. So x square, in the place of x square, I wrote x minus 0 whole square and plus 2. Plus 2 remains plus 2, okay? In this x square, I used a trick. I just wrote x minus 0 and whole square. And this is that form of the equation in which the turning point, the coordinates of the turning points are showing up. The coordinates of the turning point are showing up. So from here, I can tell you the x coordinate of the turning point will be 0, and the y coordinate of the turning point will be 2. So I know the turning point now. So that's 0, 2. So once you know the coordinates of the turning point, then you can draw a table. And if I know the turning point, that is 0, the x coordinate of the turning point is 0. So I will take 3 points before that x value of the turning point and 3 points after the turning point. So 0 at 0, the turning point is of this graph. So I will take -1, -2, -3, and I will also take 1, 2, and 3. So I've substituted these values into this original equation and found what are the values of the y. Then I will draw a grid, and I will, first of all, I will plot 0, 2. That's the turning point. Then I point -1, -1, 3, -2, 6, -3, 11 was out of this scale. Okay, so 1, 3 and 2, 6, and then I join them with the smooth curve. So from the turning point, I draw a vertical line that will be the line of symmetry. And because the vertical line is passing through here the value of the x on this line, it's a vertical line. So its equation will be x equals to 0 because it's passing through the origin, this vertical line. So its equation will be x equals to 0. You know, the line of symmetry in the parabola is always a vertical line, and its equation is always x equals to some constant. That's question number 2A part. Okay, so question number 2B part is showing up on your screen. The equation is very simple. Y is equals to -x square -6. Because the coordinates, because the coefficients of the x square are negative, so it will be a sad face. So I do a trick here. You see, minus, it comes as minus, but x square, I put the bracket, and x square, I wrote x minus 0, bracket close, square, -6. So you see, this shape is basically that shape which tells you the coordinates of the turning point. So the coordinates of the turning point, here I have written that standard equation also. So you see the coordinates of the turning point will be 0, -6. So once you know the coordinates of the turning point, you can make a table, put the turning point in the middle, take 3 values before the turning point and 3 values after the turning point. So for example, the graph turned at x value of 0. So I will take 3 x values before that. I will take -2, -1, -2, -3, and 3 values after that x where the graph took turn. So it will be 1, 2, 3. So 1, 2, 3, sorry. And I substituted these x values in this original equation, and I found the values of the y, and I've written them. So then I will plot them on this grid. And you can see turning point 0, -6 here. Here we have the turning point. Then I plotted -1, -7 here, and 1, -7 there. Then we have -2, 10, -2, -10. So this point, and 2, -10. This point, 3, -3, -15. So this point, and 3, -15. This point. Then I join them with the smooth curve. A parabola appears. Okay. So this is the line of symmetry, which is a vertical line passing through the turning point, and because it's passing through x equals to 0, so the line of symmetry its equation will be x equals to 0. So that is how you do the question number 2b part. Okay, so on your screen, question number 2c part is showing up. They have given us an equation: y is equals to bracket x minus 3 bracket close whole square plus 1. So if you open it, you simplify this thing, the x squares coefficient will be plus, so it's a happy face. This equation is the standard equation, and this is that standard form which tells you the coordinates of the turning point. So you take this value, that's the x of the turning point, but you change its signs. 3, this is the y of the turning point, but we don't change its sign. That's 1. That remains 1, positive 1. So for the x, I change the sign, but for y, I don't change the sign. So 3, 1 will be the turning point, the coordinates of the turning point. Once you know the coordinates of the turning point, I will put that in the middle. I will take 2 or 3 values before that and 2 or 3 values after that. So the graph turn at x value of 3. So I took 2 values before it, or you can take 3 values. It will be, I will take 2, I take 1, and 2 or 3 values after that point. I will take 4 and 5. So I put these x values in this original equation and find the values of the y. Here you can see them. Then I will plot them. So I draw a grid here. First of all, I plot the 3, 1, that's the turning point, and 2, 2, this is the point, 1, 5, this is the point, 4, 2, this is the point, and 5, 5, this is the point. Then I join them with a smooth curve. So you got your parabola. You can see it's a happy place. It's turning at 3, 1. And the line of symmetry will be, this is the turning point. So through which I will draw a vertical line. That will be the line of symmetry, because this is passing through x equals to 3. So vertical lines is here is x equals to a number. So that will be x equal. So that will be x equals to 3. That's the line of symmetry. So let's move to the question number 2d part. In the question number 2d part here, the equation is given: y equals to minus bracket x plus 1 bracket close whole square minus 3. So this is a standard form. Here we have a negative, so it will be a sad face. And this tells you the coordinates of the turning point. This is the x coordinates of the turning point, but you have to change its sign. And this number is the y coordinate of the turning point. You don't have to change its number. So it will be minus 1, minus 3. The turning point coordinates will be minus 1, minus 3. So once you know the turning point, x of the turning point, you take 2 or 3 points before that and 2 or 3 points after that. The graph turns at x equals to minus 1. So I will take 2 points before that. It will be minus 2, minus 3. 2 points after that, that will be 0 and 1. I will put these values into the original equation, and I found the value of the y. These are those values of y. Then I will plot them. Here you can see I've drawn the grid. First of all, I put the turning point, and that will be minus 1, minus 3 here. That's the point. Minus 2, minus 4. This is the point. Minus 3, minus 1. This is the point. 0, minus 4. This is the point. And 1, minus 7. This is the point. Then I will join them, and this is my parabola. This is the graph of that equation. Then I will draw a vertical line passing through the turning point. That will be the line of symmetry. So the equation of this line will be, so vertical line will be x equals to constant, and that is x equals to minus 1. So the equation of this line will be x equals to minus 1. So that was question number 1, question number 2d part. Okay. So here we go to the question number 2e part. An equation is given: y is equals to minus bracket x plus 2 whole square plus 3. So it will be a sad face. This equation, this is a standard form in which the coordinates of the turning points are showing up. This is the x coordinate of the turning point, but you have to change its sign. So the turning point x will be minus 2. This is the y coordinate of the turning point, and it remains as it is. So it will be positive 3. So the turning point is minus 2, 3. So you write here, draw a table here, write this turning point here, and take 2 points before that, 2 points after that. So I will put x value minus 3 and minus 4. I put them here. and I found the values of the y. So these are the y values. I got it from here. Then what I will do, I will plot them on the grid. You can see here we have drawn the grid. I will plot -2, 3. This is the point. -3, 2. This is the point. -4, -1. This is the point. -1, 2. This will be the point, and 0, -1. This is the point. Then join them with a smooth curve, and that will be your parabola. So then I will draw a vertical line passing through the turning point, and that will be the line of symmetry. And this line of symmetry is a vertical line, so its equation is x equals to constant, and that is -2. That constant is -2. So the equation will be x equals to -2. That's the line of symmetry. So that is question number 2E part. Okay. So question number 2F part, we have an equation y equals to -(x -4 bracket close whole square -1). So it will be a sad face because of this negative. So because the coefficient of the x square will be negative when you open it or simplify it. This form of the equation gives you the x and y coordinate of the turning point. This one here inside this bracket, this number gives you the x of the turning point, but you have to change its sign. So +4 will be the x of the turning point, and this gives you the y of the turning point, and it remains as it is. So -1. So the turning point's coordinates are 4, -1. Once you know the turning point, you just write it in the table, in the middle of the table. So the x at which the graph turns is 4. So you take 2 or 3 points before that, 2 or 3 points after that x value. So 3 and 2, 5 and 6. So I will substitute these values in this original equation, and I will try to find out, I will calculate the values of the y. So I have already done this. These are those values. Then I will draw a grid and I will plot these values. So the turning point is 4, -1. That point was supposed to be here. Okay. So my student has by mistake put it on 4, 0. It's not 4, 0. It's supposed to be at 4, -1. It's supposed to be here. Okay. And 3, -2. Okay. And 2, -5. That will be here. And 5, -2. It will be here. And 6, -5. It will be here. This point is supposed to be 4, -1. It is supposed to be here. That this dot should not be here. It should be here. And then you join them like this, and it will be. Let me see. I can find a pen. I can find a felt pen. So it should be passing through here. Okay. So it should be like this. Okay. That point is this one. This point 4, -1. So this is your parabola. And if you want to find out the equation of the line of symmetry, draw a line, a vertical line passing through this origin, passing through the turning point, and it's passing from x equals to 4. So the equation will be x equals to 4. So this will be your equation of the line of symmetry. So that was question number 2F part. So my dear students, today in this session we have done exercise 1E of the D3. We have done today, it's question number 1 and question number 2. The rest of the questions we will do in another session. I hope that this has been this video, this class, you have learned this concept from this. I hope that you will learn from this. If you have learned it and this has been beneficial to you, don't forget to subscribe to my YouTube channel, and don't forget to like my video. Also, if these videos are helpful to you, so ask your friends to watch them also. And share the link of my video on your Facebook and your Instagram and all other social medias which you are using, because that will be a very great help for me. It will appreciate my work and it will promote my channels, so I will be able to continue doing this. So I thank you very much, everybody, and have a good day. And